content shared in this podcast is strictly for informational purposes and should not be construed as financial or legal advice. 2. The opinions expressed by the hosts and guests are solely their own and do not represent the views of their employers or affiliated organizations. 3. None of the projects or companies discussed should be considered as endorsements or recommendations. 4. While efforts are made to ensure accuracy, the information provided may not always be up to date or entirely reliable. It is advisable to conduct independent research and seek professional guidance before making any financial or legal decisions. 5. The hosts and guests of this podcast shall not be held liable for any consequences or actions resulting from the use of the information provided. 6. All content, including text, graphics, and audio, is protected by copyright laws. Unauthorized reproduction or distribution is strictly prohibited. 7. Any discussions on sensitive topics aim to foster inclusivity and respectful dialogue, but differing opinions should be expected and not attributed to the podcast creators or sponsors. 8. By listening to this podcast, you acknowledge and agree to these disclaimers, and you are responsible for your own interpretation and application of the information presented.
Welcome everyone to episode number 9 of the Intersection 4 podcast. We have your usual 3 guests here. We have Hamis, an investor. We have Brendan, a founder and engineer, and you have me, I'm going to start saying a product guy. That's what I'm going to say from here on. And a product guy as well. And today we have some interesting topics. It's going to be an AI heavy episode. We're going to be talking about the semiconductor, the chip war, if you may, the semiconductor war, the silicon situation that the world is facing. And also we're going to talk about LLMs, and we're going to talk about LLMs hallucinations. But even before we start with any of those 2 topics, and I guess is a good segue into our first topic of LLMs, before the podcast, Brandon was sharing that he was at OpenAI's Dev Day. So, dude, I'll pass it on to you. That sounds super exciting. Like, what do you learn? What is OpenAI cooking up? And what do you make of it as a founder and a dev?
Yeah, super exciting event. There's probably about 350 developers, and they're actually developers, which is always fun. Sometimes these conferences have a lot of folks that talk a lot about the technology, but maybe aren't building in it.
Like
I was
investors,
super impressed.
Right?
Yeah.
Like us.
like you guys. No, it was just really impressive how many really great people they brought in. It was funny. There was a big leak the day before, so we kind of knew what was happening about 24 hours in advance. And some of the major ones which impacted us and a few other startups in the space were GPT-4 is now 128 character token limit. So the larger the token limit, the more opportunities you have to fit more into the context window. You can think of that as like your short-term memory, and having that ability to stick more in there allows different applications to be built, along with just longer PDFs and that sort of thing to be uploaded. So that directly impacts folks like Anthropic, who have 100K token window, which was the largest up into Monday. Other things that kind of came out of it were around some of these newer kind of like integrations in the Assistance API, and then some things that we already expected around multimodal as well.
Professor Brandon, I have a question here.
Yes.
I think I actually want to ask a ton of questions. Like, I have a general understanding of LLMs, but of course nowhere near the level of understanding that you have. So I want to drill a little bit deeper here. So you said GPT-4 now has 128 token.
1,000.
128K, yeah. And I love the analogy that you made. So this is basically like RAM, right? So this is like RAM is like the equivalent of a RAM for a computer. What defines the limits of the context window of an LLM? Like, what is that factor that is basically allowing it to go from 128,000 to 200,000? And also, just for the record, how many do you say that Anthropic had before?
Anthropic's largest model has 100,000 K token window.
Okay.
So technically the window can be as large as you want. The difficulty is being able to actually train a model. So do you have enough data to actually have a significant amount of training sets to fit into a 128K window? So let's imagine you only had 1,000 tokens of data, and you had 1,000 token window. That means you have one data point to train your model on. Whereas if you have 10,000 tokens total in your training data set and you have a 1,000 token window, then you can kind of cut it up differently and create subsets of that data. So as you have larger and larger windows, you need more compute to actually run the software. You typically need larger parameter sizes, which then creates huge difficulties to not only train the model, but then also to run inference. So the chipsets, the GPU shortage are all going to be related to, can they even train and then run inference at production time, these types of applications.
So
Okay.
other than that KPI, like what other KPIs are people striving for?
So that's one of the hardest things is there's not great metrics to date. So it's hard to know, what does good look like. And there's like an intuitive sense that people can feel like, oh, did it respond in a way that makes sense to me? So the kind of the state of the art really is actually using LLMs to evaluate other LLMs. So once you get to the upper echelon, it's hard to evaluate the best ones because they're already better than humans in many ways. And there's not a better LLM to see if it correctly did what your expectation is. That's kind of leads into the downside, which is hallucinations, because we don't have a clear indication of like accuracy and F1 scores, so precision and recall. How do you evaluate these? And I think the terminology that people started to use is when the output is not as you expect, they call it a hallucination. Can't say that word right now. But my thought on that is typically it's a problem with like a lot of the prompt engineering and the data that you're providing to the system. But there are some occurrences where it's going to veer off the path, and the reasons for why that is.
I have a few follow up questions here. So I really love the analogy of the context window being equivalent to the remote access memory of the LLM. What would you say here that is the CPU equivalent of the LLM, if any? Or do you think the analogy doesn't hold anymore?
The CPU, the actual like compute itself, is the weights of the actual model. Yeah.
Okay, and is
And what
there
about the
like
permanent storage? Is there permanent storage?
No, there's not yet. So all the knowledge is baked into the compute, into the weights, with the exception of this context window. You can almost think of that as the RAM, like you do actually have access to it. And then there's a pseudo cold storage opportunity, which you can think of like your SSD, your hard drive, is called RAG, Retrieval Augmented Generation, where you effectively have a large corpus of data and you are looking at your question or your request from the user and then trying to find, hey, out of all the documents we have in a database in cold storage, let's grab a couple of those and throw them into RAM. So that way at inference time, at the time of generation, you can reference some of them. But the difficulty is, the actual search space of some of these document stores gets very large. So there's a ton of, I think people are referring to them as like hacky solutions around RAG, but that's the kind of first in class way to have a large corpus of data that isn't built at training time.
so the corpus of data or the knowledge of the LLM is basically just baked into the weights at the moment that you train it, and ways
Yeah,
around it basically is like through RAG, which is remote access.
generation.
What is generation again? Okay.
Yeah. And another interesting update from the conference is because they've released a newer model, they've trained it on data up into April 2023. So instead of having to rag a bunch of data from the last release date to the new release date, that is now knowledge that the system has. So it knows about events that have happened between now and or prior to April 2023, whereas historically you've had to like inject more information. But there's a ton of other techniques to kind of get around this. Like for example, if you give a LLM access to a tool, which is the internet, you can tell it, hey, if something that we're asking you may be recent and you don't have access to that, you have the ability to go and do the research yourself. So the same way you give it a RAG tool, which can like jump into your database and pull in information, you can also give it searching and browsing capabilities. And this is where we kind of start touching on, part two of the OpenAI Dev Day, which is assistance, which is basically the process in which you're building not only the knowledge graph, or excuse me, the knowledge store, so the RAG tool, but also what capabilities does it have through APIs, search, browsing, and code interpreter is kind of the one that people are more familiar with today, which is a ability to run Python in a remote environment to answer more complex questions, which aren't answerable via just writing down a text response.
How are the weights quantified? So what is the quantification of weights? Like how many weights it has, or what is the quantification there?
Yeah, do you call it
Yeah,
weights because they're numerical, or weights is something completely different?
Weights of the parameters of each. Yeah.
yeah. You think of like parameters as a bunch of knobs, and the weights are just like how you turn all the knobs. And when you train an LLM, you basically have a massive amount of parameters. Let's call it like a 100 billion. And then the training exercise just pushes data through it, turning all the knobs until it finds the configuration of all the knobs that answers as many questions as possible from the training data set. So when we say like the data's in the weights, it's because all that configuration correctly gets you from point A, which is a question, to point B, which is an answer, kind of like traversing through all of the parameters.
If is each parameter at the first layer of the LLM. Sorry, does each parameter have one weight attached to it? Or so basically, if you tell me the LLM has 100 billion parameters, it has 100 billion LLMs basically. So if you were to quantify the CPU of an LLM, you're basically saying it's 100 billion parameters or 100 billion weights.
It's almost like a transistor. Like the
Okay,
parameters are
that's
like,
exactly the point that I wanted to make. Okay, okay, go ahead.
yep. No, that's exactly it.
So
It's a transistor.
what I wanted to get to here is, has there been anybody or any reputable analogies to Moore's law yet in this space? So, refresher, Moore's law was a law or a prediction, I guess, coined by Gordon Moore, co-founder of Intel, that basically said that with every few years, the number of transistors in a chip was going to double. And based on that, the compute power that was going to be available to everybody was going to continue to grow exponentially, and that allowed Gordon Moore to predict in the late 50s or 60s things like the freaking phone, or things like a personal computer in your pocket that would have been freaking inconceivable back then. Has there been
Yep.
something similar to predict the growth of LLMs, based on these two parameters, based on RAM and the context window, and also the number of parameters as well?
Yeah, I'm sure there's some paper out there which has made a reference to this. I think this notion of like parameters as neurons is just something that stuck in the last 3 to 5 years. I think in the next 3 to 5, we're going to kind of get away from this analogy, and we'll probably have a different primitive. And the reason I say that is because if you think about how smart humans are, we did that with a one millionth of the amount of data that was pushed through these LLMs. So if you kind of match our level of intelligence based off of how much data we've taken in as training data, it doesn't make sense, I think, to directly replicate this as a transistor, as a neuron, as a parameter or a weight. I think it's a healthy analogy for today, but I wouldn't extend it too farther into the future, because otherwise people are going to say, imagine a billion parameter model. I don't think there's going to be a billion parameter model. I think the idea of parameters is going to go away to a different primitive, and then it'll kind of shrink down to a new way we think about quantifying the value of parameters. And we're seeing the same thing actually in transistors. Like, it was helpful to think about nanometer technology for the longest time. Now at the point where nanometers are so small. I think 3 nanometers is the latest one. That it doesn't make actually that much help for us to think about going smaller, because now we're in like a quantum space and we just actually can't run these in the same way. So now we care more about L2, L3 caches, multi system interoperability. So you have two different GPUs. What is the like interconnect bandwidth, which is completely separate from like any one transistor's like size. So I think it's a helpful exercise today, but we're going to think of a new primitive here pretty shortly, and that'll be the new way we
What do
quantify
you
it.
think that may be? Because like the idea, like all of these parameters or quantifications are just a way to measure the growth or improvement of a technology over time. What do you think that becomes? And
And
I
this
know
is
I'm
like the
asking you to
holy
predict the
grail.
future
Yeah.
here, but like any thoughts here? Like, how do you quantify the continued improvement of a, like, anything regarding precision or something like that? Or
I don't know. All I know is the models are going to get bigger and then they're going to get smaller, because we're going to stuff more and more data into these things. and we're going to have more and more like larger and larger context windows. But the result of that is the inference is going to cost more and more to actually run these systems. So there'll be a peak of like capabilities, and then everyone's going to want to make the models smaller, more compact. There's pruning you can do. There's tons of techniques to go from 16-bit to 4-bit level quantization. So these are all like very technical terms in the industry to effectively go from these like broad base models into these fine-tuned models for specific applications. So that
Yeah,
specific
and
application might be much stronger at that specific use case as well. So again, it's
yeah,
yeah,
that's an interesting point, right? Because uh, large language models, the consumer application of them, I'm sure is massive. But for the vast majority of use cases, especially the use cases that you can charge a lot of money for, you
yep,
need a very fine-tuned model. You don't need a large language model that can answer questions about information on Reddit, right? Like it needs to answer questions about, the law in the U.S. or the technical requirements of a manufacturing facility. And so, I think that uh, charging $20 a month for a consumer facing application. Now, how much would somebody pay if it got smarter? Like maybe $30 a month, $100 a month, but there's a limit to what value a consumer can get from an
yep,
experience like this. But in businesses, businesses will shell out millions of dollars for a very fine tuned application. So I think that we're proving this out in the consumer space, but really where the money is going to be made building an AI business is going to be on very specialized applications.
yep, yeah. And the capability is only one axis that we're going to measure this by. Another is going to be speed. How fast can you run this at inference? Because imagine if there's like nanosecond level inference capabilities, you could do that real time on a headset on larger image data. So I don't think we've really cracked into these layers of like the transformer GPT style modeling approaches. And then the last thing I'll say is, we think a lot about text because it's very easy for us to intuit. But one area that I'm like super excited about is like time series. So we have a good friend who runs a time series forecasting company who trained a GPT model to do time series related functions. So the same primitive that you have text, audio, video, you have these other domains that you can train bespoke models on top of that allow it to do similar levels of um, prediction, but in a domain that you just maybe
Mhm.
struggle to actually see the value in.
Give me an
No,
example of
the
a value.
time series, like the stock market, that's a time series, right? And if
Yeah,
somebody can predict that, like tons of value there. That's immediately
yeah,
what I was thinking when you're talking about time series, because we actually have tried to internal experiments. We're not a quant shop, but we've been playing around internally with some of the Facebook profit models to try and predict time series. So I'd love to speak to this person because in our world,
yeah,
everything is a time series.
yeah, yeah, yeah. It's wild. Like the use case that I kind of explained to help people rationalize it is imagine if you have like a time series of your business's sales, and you asked an LLM, or in this case it would be a mixture model, what happens if next Thursday I do this in my business, and you see a complete new prediction get made, and then you upload a photo and say we're going to do a post online, what's that going to do to my business, and you can see a new kind of line get drawn. So like these multimodal text to image, you almost have like text plus time series to time series output, that sort of thing as well.
Hmm.
Yeah,
Very interesting. So let's talk about that's a lot of the promise, interesting stuff about LLMs and overall the technology. What about some of the challenges? So one of the big challenges that people hear about, and I think it really is kind of like a catch-all term when people don't get the response that they want to get or expect or something like that from an LLM. But help us understand what a hallucination is, why it happens, and what maybe are solutions.
yeah. So at a most fundamental level, the reason they happen is because of the data they're trained on. So if you were to take all the data on the internet and train one of these models, there'd be very well written Wikipedia articles. There'd be very fictitious essays that are not factually correct about mystical beings doing random things. There's comment threads. There's just the entire internet of data. And they actually don't train on the entire internet, but a large corpus of the internet is trained on it. So if you imagine any kind of like subsection of that doesn't include truthful information at all times, and because you don't always want truthful answers, you might say, hey, we want to talk about a fictitious child story in Shakespeare, play in this futuristic world, and that's a completely fictitious made up thing. So the difficulty is actually what we call like guidance, guiding the model to do what you expect and what you want. In many occurrences, what people call a hallucination is actually just poorly guided or a misinterpretation of the system. So I think that's how I think of like that specific scenario is, these models aren't perfect, and actually understanding what you want. I think that's what people struggle with a bit more. So when we think of like the early days, there were these base models that had more intelligence baked into them, but they struggled with following directions. So they did these down selecting or fine tuning of the model to make them instruction driven, which is called Instruct GPT, was the first one that OpenAI put out. And that's effectively what ChatGPT is. It's actually not the base model. The base model was quite hard to use because you had to tell it so many things about how you want it to act with you and respond in the correct fashion, because the way that you interact with ChatGPT is not how the entire internet's corpus is laid out. So I think majority of the issues stem from how do you guarantee the interaction is as expected from both sides. Have you guys actually like had any issues when you've tried any AI products, and how has that like
Yeah,
felt to you guys?
yeah, absolutely. And obviously, like I'm not engineering the prompts. Like I'm not paying attention to how best to explain the problem to it. I'm explaining the problem the way I would explain it to a person, a colleague, or something like that. And even though there's a layer like you're describing between the base model and me, that layer is obviously not perfect at understanding what I'm saying. So I've had, you know, just totally wrong information, like facts that it spit out, like totally wrong. I've had it say like things that I never said, and I'm asking it to summarize, and it's summarizing something like it almost felt like it was somebody else's text that it was summarizing, and I felt like for a second it had jumbled up, two people's, chats. It felt really weird. But for the most, so since that experience, I've been double checking and triple checking whatever it tells me, especially if it's part of like an email or something I'm posting. So I've started to doubt it quite a bit actually since those experiences.
Brendan, what do you think it's missing in this market, like in the Gen AI LLM market? Like it's been a year. It's gonna be a year now soon of GPT ChatGPT launching, right?
Yeah.
And there was so much excitement around this in January of this year and right after the launch, and there's still a lot of excitement about this, but of course, like the market has calmed down. We saw Nvidia's and Intel's stock go to the moon, and like a lot of volatility in the markets in response to ChatGPT and so on. But granted, if you go and look back, the personal computer revolution or the internet revolution didn't happen in a year. But what do you think is missing to like build that killer use case for consumer products particularly, not just for business to business applications, but like what's missing to build the Intel of this revolution, or the Google of this revolution, or the Facebook of this revolution?
Yeah, I think it's agents. Um, Hands down, everyone at the conference is like building it, has already built it, or is planning to build it. And all that is an LLM connected to the data that matters about you, and also has access to take action on your behalf when you want. And if you're able to do that, you've unlocked an entire market. And yeah, I think we were still like scratching the surface of its ability to actually act as like a pseudo human in many like knowledge work applications or even personal applications outside of the work environment. Yeah. I think that's the
Scary
GPTs
stuff.
or like the area that most people have like referred to this as coming out of the conference, um, and that's like the App Store equivalent is what people are referring to it as. So I think that's going to
An
produce like a
agent
bunch of interesting.
marketplace, basically.
Yep.
And the agents are use case specific. Do the companies develop them themselves? Is an agent just kind of a program that knows how to speak to the LLM really well and then
Yeah.
pass on instructions? Like, what is it?
Yeah. All of those things because like all of the hallucinations that you guys are having is probably mostly because of like prompting and then just making sure like it's correctly tuned for like the use case and then telling it time and time again, hey, you're a travel agent, this is what travel agents do, this is what travel agents do, the same way that you learn and kind of pick up those skills. These systems are quite quickly. So I think that that's going to be the biggest one. But again, this is so new that someone might come out of nowhere with something else.
Net
So is
new.
it like a app? So is it going to be an explosion like the App Store, right, where 10,000 different developers jump on it and try to create network effects around their agent? Or do you think one company can produce a bunch of agents? Like, who do you think wins here? Somebody who's super specialized or somebody who has distribution? Like, does Facebook win with a bunch of agents, or do small companies win that are super specialized in the agent they build?
Yeah, and a piggyback to that question is like, who? It seems like the agents are the apps. Who is the app store? Is it just a base model, and is the base model the winner?
I'll answer those in the kind of like in one at a time. So the analogy that helps for this one is like what the App Store did for social media. There was an acceleration of a ton of social media to begin with. Facebook basically like crushed when the App Store came out. However, TikTok is only possible because of the App Store. So there's and now TikTok is doing phenomenal. So I think depending on what time scale you think about this as, the distribution already held by these organizations will like accelerate them. But there will be like the TikTok of agents that just wasn't possible beforehand. So there, I think both startups and enterprises with distribution are going to win, just in different ways, and maybe not in the same order. So I think that's going to happen. And on the base model side, this is the interesting part because the App Store is tied to Android and Apple. Like obviously, like the gatekeeper in those cases are the app stores. There's no gatekeeper anymore. Obviously, there's really great models that people are putting out, OpenAI, Anthropic, but there's super strong models that are open sourced. And then as long as you have access to compute, which more people have access to better compute in the form of their laptops, their phones, these models will get better. They will work on edge devices and they will work offline. So that's the crazy part is you can't keep this in a box anymore. It's already out.
Let's
Sounds
talk about
sounds like
let's talk about
sounds
compute
like the
here.
Web3. Yeah, sounds like the Web3 mentality, right? So are we going to start putting AI into Web3 now? Getting out of the control of the app stores.
Probably. Yeah.
And
Yeah,
okay, so
probably.
two questions, Brandon. Here, you said there's no gatekeeper anymore. Who's to say though that like wouldn't the company that controls a given model um wouldn't they just gatekeep their own model? And like I'm trying to understand here, like if I'm OpenAI, I'm trying like from a product strategy, I guess I'm just trying to build out this agent marketplace all to work based on my models that I'm putting out, right? And of course, like I wouldn't want to have an agent that is not listed in my platform and giving me any sort of revenue by interacting with my model to be able to use my model in their front end end user interface, right? So why are you saying that there's no gatekeeper here? Because like just because there's open source models, and then I think the barrier of entry to having a really good model is just compute. And you say having decent compute, yeah, my computer is pretty powerful, but I'm sure that doesn't compare to like all of Microsoft Azure backing OpenAI's model, right? So I'm trying to understand here, like, what is the threshold of compute that we're talking about to make an open source model competitive with, say, OpenAI's models?
Yeah. The reason I think it's different is because social media required network effects, and you can't re-replicate a network effect on your own.
Yeah.
There's a reason that exists.
Yeah.
The same thing doesn't happen when you're trained on the open internet, right? So there's obviously going to be specific use cases which are trained on like proprietary internal data that require you to be on their proprietary system. But broadly speaking, OpenAI doesn't have a strategic data advantage outside of people just using their applications. So that could be replicated. The people that will have strategic data advantages are like the Twitters, the Reddits,
Reddit.
who've like said, hey, you can't train on our data anymore. And like they have a subset of data that they can over time, put out in an LLM. And then like over time today, the open source models just aren't as powerful. But that's just
They
gonna
aren't,
over
or
time.
they are?
They are not. But what came out last year, their open source models are now better than. So there's going to be a lag at all times, but the lag won't. At a certain point, the lag won't make any difference to a consumer. The same way that you can buy an HPC, a high performance computer, like a massive one. It doesn't make your day to day function as like a video editor, a designer, any different because it's reached some level of sufficiency that just doesn't impact you. We haven't reached that in LLMs yet, but we will at some point.
How much compute? Okay, so two questions. How much compute is it needed to, like, let me rephrase the question. The compute needed to train the model is much greater than the compute needed to run the model, and this is what I understand, right?
Yeah.
If that's the case, where are these open source models getting trained, and what is the incentive for the people or group of people who are doing that training to release it?
Yeah. So this is super interesting. So a good example is Facebook has found an incentive structure that has allowed them to train these models at a very high cost to them and then release them to the general public. And I think each business is going to have like a reason for why that is. But then there's also just open foundations. There's foundations where they've been given donations or they have some collective pool of donations in order to accelerate whatever their agenda is. And in many cases, it does make sense for them to have these open source models. Another good example is Databricks. They've trained an open source model because them releasing that to their enterprise customers is going to increase the amount of compute that all these companies are going to use on their systems. NVIDIA, I'm sure they've released one or they should be releasing one because the more compute that gets used, it's incentivizing to them. So there's various market dynamics which incentivize people to release open source models.
What was the incentive system for Facebook?
Yeah. So a few things. One is for them, I believe that they believe, or their thought is that the more people can get onto their vision systems, so they're like, what's the mixed reality VR? Basically, VR as a platform is incentivized by having a bunch of developers using these language vision AI systems on their VR platform. I think that's one of the reasons. There's a few others that I think are more opaque, but from what I recall, that's like one of the major reasons they're able to do so. And they also don't have any incentive not to, because at the same time, they don't own any of that compute. They don't have data systems like Google or Amazon. So for them, like, why would they not do it? Almost. Yeah.
Okay, and so moving forward, the threshold, or sorry, the barrier of entry comes from being able to train really good models, not from using really good models. What is the comparison here in terms of compute power needed to train a model like some of the most prominent open source models that exist versus just using it? And just one more question for sake of curiosity: how are these models open source? Is it just like a binary blob that you download into your computer? And what is the size of these models, and what is the size in terms of like actually storage size, and what is the size and what is the compute necessary to actually use these models?
Yeah. Yeah. So a couple of things. So to train them, the big blocker there is interconnect. So you can't just run it on one single box. So then typically you have to have a methodology to compile 5,000 NVIDIA A100s in order to train it over the course of 4 weeks, right? And it costing upwards of a couple $1 million, depending on how big the model is and various adjustments you've made over the last couple months to bring that cost down. The open source question. So there's different like levels of open source. Facebook has released the model and the model weights. basically like the architecture and then the weight of the all the like the values of the architecture.
Mhm.
They didn't release the training code though, or the training data. So there's this kind of balancing act of like you can't recreate their model, but it is open source in one facet. Separate groups, a lot of the the open source like community groups are releasing the data, the actual code to generate and train the model, and the architectures and obviously the weights themselves. So it's very inspectable. And then the last question around compute is that you can take it a million different ways to see benefits in speed. You can run them on CPUs nowadays. There's a bunch of hacks to do that, but majority of them to run efficiently have to be run on GPUs. So we actually, as a company, just bought kind of basically the nicest M3 Pro Max that you can buy, just so in demos we can give a fully offline demo of our application within an environment that has no Wi-Fi to prove to customers that, hey, we can be offline within your environment on premises to run these large language models. So that's like a great example of, the newest M3s are strong enough to actually run the open source models at an inference rate that it makes it reasonable.
That's
Yeah.
so fascinating, man. So cool. So cool.
Yeah.
James, what are you seeing from the investor side? What are you seeing founders coming to you say, hey, I'm working on this AI startup? Like, do you see the level of granularity that we're discussing here with Brandon? Do you see people like building things on a very specific corner of the AI world in the supply chain of models that is going to be like a killer 5 years from now? Or do you just see like the main use cases of like everybody's and their mother is building a chatbot and a Gmail summarizer and
An
so on?
email
Yeah.
responder.
Yeah, yeah, it's very noisy, man. If I'm being honest, there's just so much stuff out there because you not only have the companies that are building now, you also have all the companies that are shifting focus, pivoting, right, into AI, and so there's really just an absolute ton of companies. So when you have a team looking for a problem to solve, or if you have a team that gravitates towards like easy money or easy growth, they just go from trend to trend to trend, right? And so a couple of years ago, these same people were pitching us, blockchain. Now they're pitching us blockchain plus AI, or they're completely pitching AI. And so there's no, like, you can tell within the first 5 minutes whether they've paid the price of being an expert in the field. And that's what we really look for, right? Because if you're just trend hopping and nobody on the team has paid that price to like really have grinded out and painstakingly understood the intricacies of any technology, it doesn't matter, then you're not going to be able to compete with the best because the best are doing that. So it was actually similar questions. And when we invested in blockchain companies early on as well, it was, why does a blockchain even make sense here? Why can this not be done with a database? And what have you done to painstakingly become the expert in the world on this specific use case or specific technology? And when you ask those two questions, about 95% of companies fail in those two questions. And same question in the AI space, right? And more than actually, I feel more than 95% of the companies fail on the AI side because of this like tourist mentality and this pivoting mentality that's coming. Because if you started a blockchain company, like, chances were you at least like believed in the overall thesis, because it was a very volatile thing. It was also a very divisive thing. So if you told your mom you were starting a blockchain company, like, it was quite divisive, but when you tell your mom you're building an AI company, that's not very divisive. Like, you actually, that's a good thing. So I think the percentage is probably even higher of what I'm seeing. But it did go from very basic wrappers. Like, for example, when the code interpreter was launched, that killed like hundreds of businesses that I was pitched, about 6 months ago or a year ago. because that was just basic functionality, right? And OpenAI built it through. So I've definitely seen the sophistication level go up to get past the first few stages, because they used to just be wrappers that in a couple of months I could see OpenAI like coming up with that feature and then killing this entire segment of businesses. And then agents, just like Brendan is seeing, agents are or fine-tuned solutions um, are the talk of the town, at least for the last 3 months. And so that's one. So find more fine-tuned solutions. Second, that's very interesting to me, is at the intersection of multiple technologies, um, and taking advantage of like the latest tech available, like across the board. So today, blockchain and AI concept was pitched to us. Like that is now very interesting to me, because it's taking the best of those two worlds of technology that's both like ready to use today and actually solve the problem. And you put those two together, you really come up with a interesting, innovative solution. So that's what I'm seeing across the board, and lots to learn for sure.
Okay.
Yeah.
Okay. Fellas, I think we are 7 minutes out from our time. As it is, I guess usual, we never got to the second topic here of the actual hardware that is making all of this possible through chips and the interesting dynamics that we have in the world with chips. And I guess I'm also always trying to take the conversation more to the geopolitical side of the house. But I would say let's table this for the next pod, and let's call it here. Any final remarks, Brendan and Thomas?
Good fun.
Yeah, like one question, Brendan. So, for like if you are an entrepreneur today and you're building on top of one of these models, or you're building one of these models, like how do you solve for hallucination, if you solve it at all? Just I want your experience to kind of lay out a roadmap for somebody, right? Because a lot of people, this is one of those common questions that get asked,
Yeah.
from investors, from customers, like what should the answer be, or what should the solution look like?
Yeah. I think the agreement in the space for investors and founders right now is you are either a modeling company or an application company. You probably shouldn't be both. So what we mean by that is like you can build the next base model or you can build a fine-tuned model. But right now it's very, very hard to fully develop the model or like fine-tune a really specific model as well as build the entire application layer. Though there will be companies over the next few years that do both, and I think they'll be very successful. But I think near term, you have to decide as a business which one you're going to be, and then you have to lean into that. So if you're a modeling company, you are building more instructable, fine-tuned models for your customer base, and you're effectively like helping them solve that solution by not requiring them to describe as much to the system in order to get the correct response. Or on the flip side, if you're an application company, you need to create a large amount of guardrails in like traditional software sense, as well as feedback mechanisms in order for this to be reduced over time. And I think those are just more traditional software best practices. I think people have over exaggerated these a bit. I don't think they're as prevalent as people make them out to be, at least in like the good applications. I think, yeah, if you have like a light wrapper around any model, it's not going to work well, but that's just, you just have a bad business, and you can't blame it on the model for just having a bad business and not putting in the work. The same way that if you were to design a product poorly and you're like, hey, for some reason, whenever we use this, maple, this wood type, we always get bad tables. It's like, well, no, you just are poor craftsmen. So I think there's like this, people are passing the buck to the modeling companies where, they've given you a lot of tools. You just go build a better system. It's not all the modeling fault. Yeah.
Good. Good.
Thank you, very
Okay,
helpful.
folks. Well, thank you
Fun.
all for the time. And another good episode as always, and we'll see you back here in 2 weeks.
All righty.